Okay, we're going to look at another technique of finding limits algebraically. This is called the conjugate method. So we're going to use this when we have 0 over 0 in a problem and you see a radical. Okay, so the big connection here is you want to look for a radical. When you see a radical, think, okay, I want to multiply by the conjugate. So the conjugate is simply the opposite. So the conjugate of x plus 5 would be x minus 5. The conjugate of x minus 1 would be x plus 1. So you're simply changing the sign in the middle between the two terms. So first of all, in our example here, if we were to plug in 3 into this and very carefully simplify it, you would get 0 over 0. Okay? So expect that in a lot of these limit questions. So notice we have in our numerator, we have two terms. We have the square root of x plus 3, and then you see minus, and then our second term is radical 6. So you have a binomial here. Notice there's a radical in it. You don't have to see radicals in both parts, but at least one part. So what we're going to do is we're going to multiply the top and the bottom by the conjugate. So the conjugate, so the terms will stay the same. We still have this radical x plus 3. Alright, and then we're going to have a plus radical 6. The only thing that's changing there is the sign between the terms. So I'm going to apply this to both the numerator and the denominator. We're not changing the problem at all. We're really just multiplying by 1, since anything over itself is 1. So let's clean this up. The nice thing about multiplying by the conjugate is when you go to do your FOIL here, the inner and the outer terms are going to cancel each other out since you have opposite signs. So we really just need to account for the first term times the other first term, and then the last term times the other last term. So when you do this radical x plus 3 times itself, it's really quantity squared. The square will cancel out the square root, leaving you with just x plus 3. So we're going to have x plus 3 when we multiply the first two terms. Again, when we do our FOIL, the outer and the inner, they're going to cancel. We're not going to bother to write it. What we're left with is negative radical 6 times a positive radical 6. Well, that's just going to be minus 6, since you would have negative radical 36. Square root of 36 is 6. So then all this in the bottom here, we're going to keep this in factored form. So I'm going to rewrite this as is. You don't want to attempt to distribute, because our goal is always going to be to eliminate a common factor. So when you do this method, you're always going to find a common factor. Well, notice if we simplify this up top here, this becomes x minus 3. Okay? So that x minus 3, when we simplify it, notice that that will cancel out with the x minus 3 that we see down below. So we have a common factor. Now what's left up top here, if we look at this entire fraction, what's left up top is 1. So from here, what we could now do, since we've removed our common factor of x minus 3, by the way, you would have a whole at x equals positive 3. What we're going to do here in our last step is substitute in x equals 3 wherever we see an x remaining. So we're going to have 1 over. So I can drop my limit notation now because I am plugging in 3 for x. So we're just going to carefully plug in 3 for x and then simplify this. So 1 over radical 6 plus radical 6. Please don't tell me that's 1 over radical 12. Radical 6 plus radical 6 is 2 radical 6. And we'll leave our answer at that. So that's multiplying by the conjugate. Again, you want to use this technique anytime you see radicals in the problem, and it's only going to be applicable when you see 0 over 0. So make sure you see that first step.